Welcome everybody to the Lumecon Retrofit Process webinar. My name is Bob Hahn, and I appreciate you taking the time out of your day to spend with us reviewing the retrofit process here at Lumecon. Now, there's two definitions of retrofitting. One can be you actually remove a fixture and put a brand new fixture on to a pole. And many people refer to that as retrofitting. But here at Lumecon, we actually when we refer to retrofitting, we are talking about taking a current fixture and upgrading the technology in it to LED. So let's get started. Lumecon is located in southeast Michigan. We're just northwest of downtown Detroit in Farmington Hills. The reason we really mention this every single time is that we want to make sure you understand that, especially in the retrofit department, that these products are U.S. made. We're bending the metal, we are painting the metal, we are placing the LEDs, having the PCB boards made, and then bringing it all together and assembling, designing, and shipping from our establishment here at Lumecon. So it's about as U.S. made of a LED product as you're going to see. So let's get right into the process. Step one is identifying the fixture. So why retrofit an existing fixture? And that's a great question. Many fixtures are historical. They're irreplaceable. They were designed, they were casted back in the 40s, the 50s, sometimes even earlier than that. And so a town, a township, a village, a city is going to want to hang on to those. In fact, many of those are built like tanks, they're heavy casted, and they will last a very long time. So they want to upgrade it though to LED to enjoy the savings and the longevity of LED arrays, but yet keep their look and the original fixtures. Other reasons why you would want to retrofit is maybe you recently purchased a brand new fixture and you just don't want to invest in another new one. Another reason could be that the product is hard to reach. So you can think of a swimming pool, an auditorium. A lot of those fixtures are on a track-like system, so replacing the guts of those is much easier than taking down a fixture and putting a new one up. And it's also way more cost effective as well too. And then even in like food processing and everything, a lot of times those products are actually cemented into the walls or plastered into the walls. And so there's an application there where you would then retrofit the inside of that fixture. So we just spoke about, but upgrading a product from an HID or incandescent or other type of technology to LED is definitely cost effective versus putting a brand new fixture, a brand new LED fixture up. Secondly, every single retrofit kit that we make comes with a 10-year L70 all parts warranty. And we'll talk about L70 a little bit longer later in the webinar. We actually thermally test every single retrofit solution. We require that someone sends in the fixture one time, and we design and install the actual LED array, and we thermally test it just like we would a brand new product. Our in-house specialists, our R&D team, they're the same people that are actually designing our brand new fixtures are the ones that are actually designing the retrofit kits as well. So you're getting the same quality, the same care, the same professional process to designing these retrofit kits that you're getting with our brand new products. And last but not least, why retrofit? Well, one size fits all is often untrue, an untrue statement. And so you'll find a lot of companies have retrofit kits and or corn cobs type screw-in fixtures that proclaim to be one size fits all. And so here's a good application gone wrong, and that is that you have a lantern style fixture In many cases, these corn cobs are not optically designed to be in this environment, so there's actually a lot of horizontal light being thrown off and not a whole lot coming down to the ground. Also, too, the actual corn cob itself is not necessarily designed to be held by a ceramic socket. That socket before that was designed for a much lighter lamp that would be inside of it. So with vibration, maybe trucks rolling by, the wind, everything else is causing vibration on poles with the fixtures, and that can actually lead to cracking of the socket and sometimes even cracking of the LED corn cob itself. And then you'll find them dropping or laying in the bottom or sideways tilted. And you're in many cases, finding that it's not doing what it was supposed to do to begin with. Also, too, thermally, many of these are not designed to go inside of an enclosed fixture. There's just not enough heat sinking going on. There's not enough thermal transfer. So with Lumecon, we design every single one of our retrofit kits to be actually connected to the casting of the fixture so that we create a thermal path for the heat that's being driven by the LED, created by the LED, and we actually then dissipate it out of the fixture into the ambient environment. With these corn cobs, actually, some of them try to use a fan, or other means to try to dissipate the heat, but what ends up happening is that it gets very warm inside of the fixture, and then the fan is just blowing hot air around. So identifying a long-term solution is extremely important. So when you take a lot of LED dyes or a lot of LEDs and you cram them into a small area, and especially an enclosed area, it becomes extremely difficult to shed heat, and it does limit the lifespan of the product. So when Lumecon designs a retrofit kit, we spread the LEDs out, we put them onto aluminum, we make sure that the design is that using existing boss heads so that we can actually attach the fixture to the current existing housing so that we can then shed the heat, give more breathing room, and on average, we're going to run about 20 degrees Celsius cooler than a corn cob or an other type of retrofit kit that's cramming a lot more LEDs into a smaller place and not creating a thermal path. What does that mean? Well, that means we're lasting probably about twice as long. In some cases, 100,000 hours or more. So when we talked about L70, the human eye really has a hard time picking up a difference in light output up to about 19%. Once it hits about 20% difference between two lamps or two LED arrays, you start to see the difference between the two. So in the world of LED, we actually have drawn a line in the sand and said that a 30% depreciation from a brand new array is the lifespan of the LED. So we take the next step at Lumecon and we actually warranty that, meaning that if you put up a fixture today and you measure 10-foot candles under it, if you went back 9.5 years later and measured anything less than 7-foot candles, then we would warranty that. That's how much we believe in it. And we've been in business now going on almost 16 years, and we have proof in the pudding that we can stand up to that. So step 2 is completing the request form, which is extremely important so that we have all the data that you need to be able to do a successful retrofit kit. We do need the job date, the customer name, the job name, what type of application is it, what type of fixture is it, existing wattage, and that's extremely important because in many cases, when you'll see here that we look for the existing voltage, the quantity, but sometimes when we're asking about light levels, a lot of people are like, I am unsure about how many foot candles, are out there now. And so we say, okay, well, what is the wattage of the current HID fixture? And then we can base off of that a pretty good equivalency, of an LED array in that fixture to then mimic what was in there before. And so the mounting height is also important as well because it determines what kind of optics we're going to use. The lower the actual mounting height, the more we're going to spread the light horizontally, and vertically, but, we'll spread the light even further. And then the higher the fixture, then we would have a different type of optic on it. So that does determine what we're going to do. Again, you can see why one size fits all really is not applicable. There's so many variables. Now, we also have a notes and a goals section too, and that is, anything that may need to know. Is there anything that that can add to us helping us design a proper fixture, and also what the goals are. Do you want to have this project done within 2 months? Is it 2 years? The goal is to provide 2,700 Kelvin temperature lighting. Whatever it may be, that some other extra notes that we need to know. So required items. First off, we just talked about the request form. You can email that to us, or you can mail that in along with the fixture, because the second thing that we need is a sample fixture. Now, why do we need this? People ask a lot. Well, again, like we said earlier in the webinar, we need to actually design exactly to that fixture. We need to do thermal testing in that fixture. And then when we're done with it, we have all the design parameters that we need. We no longer need that fixture anymore. We will deliver it back to you with the sample inside of it. And so that's why we need the fixture. Another reason is that when some people say, well, have you done this fixture before? And sometimes the answer is yes. Yeah, we have done that before. So, but we still need the fixture. And the reason is that a lot of fixtures can be 40 and 50 years old. And what that means is that over the years, they've actually changed the tooling on it. And sometimes they've moved boss heads, they've moved lips, they changed the way they close it. There's all kinds of improvements that they've made over the years. And so we need to know which model is this and which year is it. And then that way we adapt to that, and so that we can make something that works for you. And last but not least, we do require a purchase order of $500 for the very first design. And with that, you do get a sample in the fixture back. And then also, we will do a specification sheet for you for that exact fixture, and then also install instructions as well. 2 reasons why we require the purchase order. One is to keep track of everything and to be able to keep a process going. And number 2 is that we have found we actually used to do this process for free back in our earlier days. And we found that that we were getting an extremely low closing ratio, meaning that maybe the end user really didn't agree to it, or maybe they didn't have any skin in the game, so they weren't really worried about it. So we find that requiring a $500 purchase order from the end user, or along the way, you have everyone's attention, everyone's involved in the process, and they're looking forward to results. And in many cases, then the closing ratio of this process goes way up. So you would send the product to us here at Lumecon and put attention to our retrofit division. And like I said, you can email us in the form, and then even helps to then take another copy and put it in the box with it so that we know what goes with what. And then we will begin the process. So what we normally do is we take the fixture out of the box. We actually tag it with a big tag and we put on there, we assign it what's called a D number, a development number, and then we also put the name of the customer on there, as well as a date, so that we can track the fixture, make sure we don't, misplace it. It stays in the process, and we can then give it back to you. So the R&D team will then, once we have the fixture, they'll custom design and build a proper LED retrofit solution for that provided sample. It will be U.S. made. It will be made in Michigan. They also take specific measurements and record with micrometers the actual fixture itself, and then they draw the actual fixture in CAD as well. The reason we do that, again, is what we talked about, and that is we're developing install instructions, so we like to show the entire fixture and how it goes in it and how it attaches. And then also, too, like we talked about, if for some reason the fixture ends up being exactly the same as one we've already done, that can shortcut the process quite a bit for us. And we can identify that through measuring the fixture out and making sure that all the boss heads and the lip and the design is exactly the same as another one that we've had. And then I said that can actually help shorten the process up. LED light engines are designed in CAD for precise connections to maximize thermal dissipation. And again, we talked about making sure that the connections are made between the LED array and the housings. Now, not every housing is the same. So for example, if we are, one of the goals is to do a 150-watt LED array inside of a fixture. Well, if it is a heavily casted fixture, nice thick aluminum, that's probably not a problem. Those are very good heat-sinking materials that we work with. Now, in many cases, someone has sold a very inexpensive fixture, but it looks just like the nicely casted fixture. And so, having said that, those are a lot of times made out of spun aluminum. Spun aluminum has very, very few thermal dissipating properties. And so, when you're trying to dissipate heat to spun aluminum, it doesn't work as well. So if we're trying to achieve 150 watts, we may only be able to do 75 watts in there. And this is a good opportunity to talk about what our parameters are when we're designing. And that is that we have to run approximately no more than 80 degrees Celsius at the most inner LED, or else we'll reject the design. So because we had a 10-year warranty to stand behind, we need to make sure that the array and the driver are running at a certain temperature or less. So they do the design in CAD, draw it up. We have a local fab shop, then fab up all the aluminum that's going to go into the retrofit kit. Then those prototypes are returned to us. We then install the LED and we put it into the array. You're seeing a picture here of 3 thermocouple that have copper wires that go to the LED array and also to the LED driver. And in this case, they're also measuring the case of the temperature of the housing itself. And again, using all of that data tells us whether or not we can hit that 150 watts, if that's what we're trying to achieve. If we are burning too hot, we'll then back it down and we will find where we can hit. And then if the goal was 150 watts, but we can only do 120 watts, we will deliver that back to you and you can install it and we can see if that's enough light. Again, most of the time this is a visual inspection after it's done because we're not putting it through a goniophotmeter unless you would like us to do that. We can do that, and we can also send it through UL as well. Again, we would quote you up front if those are requirements. But in general, only our L-Retro DG and some of our other off-the-shelf retrofit kits that we have are UL and DLC. The rest of them are custom designed for exactly that fixture, and unless it's required for UL or DLC and or photometry, we don't normally do that as a case. So components are manufactured and assembled for testing. They put together, they assemble the entire actual array. We're only using Tier 1 componentry, so again, we're using a lot of Nichia, Cree, Samsung, Osram LEDs. In the world of drivers, mostly we use Philips programmable drivers, some Thomas Research, some Inventronics. All of our connections are made with a very stringent top of the class Wago connectors. If we're doing photocells, they would be solid state. They're going to be something like an intermatic solid state. Occupancy sensors, we use a Legrand wand stopper typically, or a microwave, all top of the class. And then every single fixture does get a 40 kV surge suppression unit installed as well. That is a standard item that we put on every single brand new fixture and every retrofit kit. So you can see that we have an empty housing here. They have designed in CAD an LED array that would go inside of it, designing the aluminum and the actual panels that will go into installed into the fixture. We show it here in CAD, how it installs into the fixture, so it can actually still rotate and everything as well. And showing you the back side of the driver and the surge suppression that are inside of there as well in this cutaway. And then another angle of it inside of this housing. You can see that we're running the AC wires in using the Wago connectors to secure it. So then we actually make the attachment. We've already drilled out the holes that we need in the aluminum package that we put together. Then we line up the array. And in this case, we actually have two drivers in this because this is, I believe, a hospital interior fixture that wanted some redundancy so that if one driver did go out, there still is another array would be lit, so that it's called split circuit. And in this case, that was one of the goals or one of the requirements for the project. So you can see here the little fuse 40 kV surge suppression is running to both of these drivers so that it's upstream of the drivers. If there's a surge, it will take it before it hits the drivers or the LED array. Then now we're prepared to install the LED array. It's now installed, and then we test it, by running it, putting the thermocouples to it, and making sure that everything passes all of our test parameters. So we talked about giving you a cut sheet. So we design up a cut sheet for you. The delivered lumens and the efficacy are typically projected by whatever LED boards we're using. We know what they do in our normal products. So depending on whether they have a lens on top of them, no lens on top of them, or a frosted lens, we'll adjust the efficacy that we're projecting, as far as estimating the delivered lumens and estimating the efficacy. And then also all the other data that goes along with our warranty and the technical specifications of the products that we're using. We did talk about putting a surge suppression in every single one of our products. So it's a 20 kA, 40 kV surge design. It's for multi-strike. It's a metal oxide varistor designed to our thermal dissipation standards. Obviously, surge is something that you have to worry about out there because of irregular voltage, lightning strikes, and all kinds of other types of dirty power that can exist. And so whether it's a large strike or maybe it's death by paper cuts, you can end up with LEDs being blown out, the circuitry being compromised, drivers being rendered useless. So the metal oxide varistor stands in the front of the whole process to be able to absorb small strikes, or it can take, on the large strikes that come down, and it will wear away at the oxide layers of the actual MOV. So that's there, and if for some reason it does wear out the metal oxide varistor, we do fail open, meaning the light will shut off. So if the light is off, the first thing to check is the metal oxide varistor expended. You can actually pull it out and wire directly, turn it back on. If everything comes back on, you know that the MOV has been expended, and that you probably have a power issue somewhere. Unless there was a lightning strike the night before or something along those lines, maybe you're getting some kind of unbalanced power feeding into that circuit of fixtures, and that should be checked out. So the sample retrofit production products carry the standard 4-week lead time. So once we receive the fixture, to design the array, design the LED boards, then to send out to our local fab shop to have all the aluminum bent, painted, and cut, drilled, and brought back. Then we install the LED array. Then we do all of our testing. That's typically a 4-week process, and we try to speed that along as much as we can because we know it's very important to get back your fixture, but also setting the right expectations to your customer too of when you will have it back. And so once it's done, you will receive the completed sample for evaluation on the project. We understand that a lot of HOAs, the city, municipalities, city councils, there's a lot of decision makers involved typically in these types of installs, and so we need to get you that sample back so you can have it put up, and then the decision makers can then review it and say, yes, that is what we want to do. Some examples of successful Lumecon retrofits: we've done the top hat type fixtures, we've done teardrops, we've done bulkheads, we've done existing shoe boxes, decorative sconces, up-down sconces. But if you want to get a look at a lot of what we've done, we do keep a retrofit catalog of some of the most, trying not to duplicate things, but, trying to give you a look at all the ones we've done. So lantern style, in this case, this middle one here, this high bay, was from another manufacturer who no longer manufactures them. And so, but the housings are still good, and as those LED arrays failed, the manufacturer had gone out of business, and so they were looking for solutions, and we developed a retrofit kit to go inside of them. And again, we're giving that retrofit kit a 10-year warranty to go in there. This last picture here is actually out of a food processing plant, and these were plastered into the ceiling, so they were not really removable. So we developed a lay-in kit that you go over the ceiling, through the ceiling, and drop them in. Some other looks here: up, down sconce. So we have light going up and down with surge suppression and drivers. We have here a teardrop. This is a mission bell type looking fixture. Then we have more lanterns and sconces and decorative fixtures. This is a 10-foot bollard that came in from Nintendo's headquarters that we were able to retrofit. And then some other, different various looks that you see out there. So what's next? Once we develop the sample, we'll actually then put our BOM together and give you sample pricing. Usually it's set up on volume, 1 to 10, 10 to 20, 20 to beyond, and the more volume, the actually less expensive it is. Some communities only have so much money to spend every month or every year, so they only want to buy a certain amount in a certain amount of time, and that's okay. So that's why we do the volume pricing. So if you want to buy 10 at a time, you can do that. If you want to buy 30 at a time, you can save some money and do that. So we do provide you the pricing, and we're very, very competitive typically in the pricing of these retrofit kits as well. And then your design is stored for all future projects. So if for some reason they only want to do half today and half in a year from now, we will have the design on, in locked and loaded, ready to go, and then we can just reorder up all of the metal and the boards and assemble everything again and reship. So we have a lot of communities out there right now that we're working with that we get small orders every month, every quarter, every year, and we have all of those designs stored, and we don't have to ask for the fixture back. So again, upon approval of the mock-up, appeal submission then for the rest of the fixtures releases the project to full fulfillment, and we get moving on to make your job a success. So online, you can find our form. It's right here under the retrofit section on our website. You can fill out this section and just send it in with the fixture or email it in. So basically, that is the Lumecon retrofit process. We appreciate your time today. If you have any questions, feel free to email me at bobhahn@lumecon.com. That's BOBHAHN @lumecon.com. and I'd be more than happy to answer your questions. There's also sales@lumecon.com, which then they can answer your questions as well. Thank you for your time, your patience, and we look forward to doing business with you in the near future.